So this problem really screams conservation of energy. It deals with the change in vertical position of an object and the change in speed. It does not deal with time. This is important to be thinking about as we go through this unit because you're going to want to know when to use the strategies that we are talking about. So the key idea is that we want to know the speed here at the very beginning once it's released from the spring, and what we know about is what's going on at the very top. We know how high that track is. It'll be twice this distance here since that's the radius, and then we also know its speed. So basically at the very top we know the total energy, and we can say that that would have to equal the energy at the bottom. And so that's the main idea of how we approach these questions, that at the bottom the object would have kinetic energy only. We would consider that to be the lowest point of the object's motion, so potential energy would be 0. And then at the top it would also have kinetic energy, so I'm going to call that bottom and top. And then it would have potential energy, gravitational potential energy. So you can see that although the problem gave us a mass, it can actually be canceled out. It's always a good idea to do that if you can, so that there's fewer things being entered into your calculator. And then we know all the kind of final information. What we don't know is the speed at the bottom. So 1/2 times our speed necessary at the top squared plus, we'll use 10 for g, and again 8.4 is going to be our height because it's twice the radius, and so we do some algebra here and find that this would be 19.1 meters per second.